Alright, so guys, we already discussed right here this morning, we said that this is probably going to be one of the most important things we discuss all year long. So I want you to put up here a note and say that this stuff is very important. Alright? Very important section. Very important. By the way, is Mrs. Miller here? Did anybody know?
No, I don't know.
Haven't seen her?
No clue.
Okay. Alright, so take a second and get that note down right there that this is going to be really important to make sure that we know what's going on in this section so we can progress through the rest of the year successfully. Guys, 2.2, title of this is called the Distributive Property. Alright. And goal-wise right there, it says to use the distributive property to write and evaluate equivalent expressions. Alright? I'll put something up here on the board real quickly and ask you a question, alright? Suppose I put the following. Suppose I put 3 times 4 plus 6. Now guys, by order of operations, we know how to evaluate this right here. I would have to look at the parentheses here first, wouldn't I? What is my 4 plus 6 in parentheses? 10. And then 10 times a 3 would be a 30.
30.
Alright, so you guys agree that value is 30, right? Nope, no worries. Alright, so let me write this down then. Let me write down 3 times 4 plus 3 times 6. Now guys, when I look at something like that, what operations would you have to work with first?
Multiplication.
Multiplying, right? So right here, what's the product of 3 and 4?
12.
And what's the product of 3 and 6?
18.
So what's the sum of 12 and 18 get you?
30.
And over here you told me this was 30, right? Okay, so what are you going to say about these two expressions up top that I started with? If they both equal 30 or evaluate out to be 30, what has to be true about the expression on the left compared to the expression on the right?
Yeah.
Equal.
They're equal, aren't they?
Yes.
Okay, so my question might be this. Does what I have on the left look exactly like what I have on the right?
No.
Okay, so we can write expressions in different forms, but they can still be equivalent. All right. Notice what I have up here, guys. Were there any parentheses on the right-hand side?
Nope.
Were there parentheses on the left-hand side?
There we go.
Okay. What I want to get to today is this. In your notes, on the front side then, oops, come on. In the notes on the front side, our goal says to use the distributive property to write and evaluate equivalent expressions. I might make a note right up here. Distributive property allows you to do the following. It's going to be a way to get rid of your parentheses when, I'll just say when you rewrite expressions. And I'll show you what this means here in a second, okay? Squeeze it in there, all right? It's going to help you get rid of parentheses when we rewrite expressions, okay? All right, so that being said right here, gang, the following is in the vocabulary. First of all, it says equivalent numerical expressions. Basically, these are going to be expressions that have the same what? Value. If I look back at this right here, weren't these equivalent numerical expressions because both of them became what value here? 30. Okay, so these are going to be equivalent numerical expressions. They equal the same value. All right? Then the other part of our vocab then is this. We can have numbers in there. We can also have some letters. And that's where I get at with the equivalent variable expressions. It's going to be the expressions with the same value for all values of the variables. In other words, this is going to have what in it? Going to have letters in it. All right? Okay, distributive property. Down here is some toolbox, if you will. I'll go ahead and highlight it. This toolbox right here, it looks like a bunch of hippy-dippy baloney. but it's pretty important stuff, all right? Is that funny? You guys know who says hippy dippy baloney? I do. You guys haven't seen the Lego movie? Are you kidding me?
No.
Oh, I want
President
I want to
Business?
so bad.
Maybe I should just bring it in. We'll just have a day.
Really?
Maybe that's
Can
what I
we-
should do with the first day of the new HD projector
Yes.
they're buying.
Yes, let's do it.
Yes.
Yeah. How about, listen, I'll let you watch that movie. How about with the days before Christmas break? I'll let you watch it. Is that a fair deal?
Yes.
Party and
Yes.
bring food. Like,
Yeah,
like,
we'll have a
I
breakfast.
don't wanna watch the Lego.
Is it a deal?
Yes.
Either that or Guardians of the
I gotta be
Galaxy.
honest with you. Great movie. I
wait,
love
did
that
I
movie.
record you saying that?
Either that or the Guardians of.
I'm recording right now, so
Oh,
you've
yeah.
got it online.
I cannot speak today.
It'll be on
Taryn, you
YouTube,
had your
Taryn.
long moment there.
Okay.
Wait, you're putting.
Yeah, we'll figure a way to bank some time and get ahead a little bit, and we'll do that maybe right before Christmas. How's that sound?
Wait, it can't see us. Can it?
What's that?
It can't see us, can it?
No, we can't see you.
Okay, good.
Actually, it can't. It's been spying on you the whole time, Taryn. I'm kidding. All right, gang. Take a look at what I've got up here. Really important stuff. It says a distributive property. And I'm going to kind of go ahead and draw a line in the middle. I think you guys have a line in the middle there anyway, don't you? All right. What I want to get at is this. I'm going to draw some arrows with just a marker, and you're going to want to do the same on your notes. But guys, right here, the distributive property, there's 4 different forms of it right here. Notice that everything that's on the left-hand side in these expressions right here, and in other words, this is A times B plus what?
See.
And what is B plus C inside of?
Right.
Notice that everything here on the left-hand sides all are in what? And which variable is either on the left side of the parentheses or the right side of the parentheses? The A is, okay? Now I'm telling you in this example right up here, and I'll draw arrows for this first one, but in that first example right there, it says A times the quantity of B plus C. Anytime you hear me say the quantity of, if you ever hear the quantity of something, that just means what is around that mess? Parentheses, okay? So when I say A times the quantity of B plus C, the quantity of means this B plus C part in parentheses, all right? What's it say it's equal to, gang? Right up here in that first one.
AB plus AC.
AV plus AC. Here's how this works. Distributive property. To distribute something means to hand out, doesn't it? If I said I was going to distribute all of my money to you evenly, what would that mean?
Did you give us?
Let's say I have all $20 bills. I want to distribute a 20 to her, a 20 to her, a 20 to her, a 20 to her. She might be B, she might be C, she might be D. All right? I might be A. A gave to who first? A gave to C. A gave to D. Well, that's what's going on right here, guys. In this example right up here, this AB right here really comes from saying, I'm going to give A to everything inside of parentheses right here. So I'm going to have A times what here first when I do this? Well, A times B. Ah, it didn't work out very well. Okay? Isn't that this part right here? Isn't that part right there? I also need to give the A to who else in there?
See?
So I take the A times the C. Okay? Basically what a distributive property works is this. Anything that's right in front of the parentheses or right behind the parentheses gets multiplied to everything inside of that. Okay? Does that make sense? Who said no? Who said no?
I think Jimmy. No,
Why'd you sing it? What's up?
I don't
All I'm doing is taking this A times everything inside here. So this becomes A times B. That's this first part.
know.
Plus, then bring the plus sign over, and then A times what? Likewise down here. A is not in front, it's actually where? In the there. But if I bring the A in right there, isn't the BA right there? And if I bring the A into the C, isn't it that part right there? Your rule really is to take what's outside of parentheses and multiply it to everything inside of parentheses. And once you do that, it's basically taking the parentheses out. Right. So numerically right here, gang, just check this. I'm going to rewrite this on a different page, but remember what I have right here, okay? This is what I'm looking at. And I'm not going to go through all of these because you can read these. Whoa, I didn't want to do that. I want to rewrite this on a different page so I have some room to work. And again, this is just one of those deals where you have a numerical expression. So wasn't it 4 times, wasn't it 6 plus 3? Is that what it says?
Yeah.
All right, and I'm telling you that that's the same as, okay, what's it say? Well, guys, what would I have to take 4 times first? So they're saying this is equal to 4 times 6. Now, since there's all numbers up here, couldn't we evaluate that right off the bat?
Yeah.
You could, but in the notes it's written as 4 times 6 plus what? 4 times 3, okay? Do You guys agree that I took the 4 to the 6, that was this part right here.
Yep.
And then I also had to take 4 times what else when I bought it in there? Whoa. Funny looking arrow, but you get it. 4 times 3 is this part, isn't it?
Mm-hmm.
Let's see if these are equivalent. What's the 6 plus the 3 right here, everybody?
9.
So this is really 4 times what value?
9.
And what's that product?
36.
Good. All right, my next one. Help me out here. What's 4 times 6?
24.
What's 4 times 3?
4.
How about the sum of 24 and 12? 36. I have a question. What's true about those values?
Same.
They're equal. So what has to be true about the expressions that were written numerically in your notes? They're the same. All I did was distribute 4 to everything inside of the parentheses. Does this make sense? What property is this called again? Distributive property. One of the most important things. Mrs. Miller, help me kind of explain to them how important this is moving through the year.
A lot.
If you don't know this, we'll be in trouble, right? And I think at the top, the notes on the first page, Mrs. Miller, look what we wrote. Would you agree?
Yes.
All right. All right. So guys, do I need to go through the rest of these, or can you kind of say, yeah, I understand why these are equivalent? Just look at this third one right here. Why are these equivalent? What happened to go from the left to the right here?
A times.
The A times what first? That's this part. And then the A times what? C. Okay, do you understand how to read this here? There's many examples right in here about distributive property. Okay. Now guys, if you really get good at the distributive property, I want to make you understand that distributive property allows you to do things mentally very quickly. All right? And let's see if we can't apply an example right here of distributive property in a real situation. So, in example 1, I need somebody to go ahead and volunteer to read that for me. And we'll see if we can't figure out what the heck is going on here as it would relate to what we're talking about today with the distributive property. Tim, you got it?
Yeah.
Go ahead.
You are buying beads for a craft project. You need gold, silver, and white beads. A bag of each type of beads costs $3.99. Use the distributive property of and mental math to find the total cost of the beads.
Okay, so right here it says we're buying, let's just highlight our important information. Okay, it says we need to buy, what colors, guys?
Gold, silver, and white.
You need gold, silver, and white, right? Okay, so how many bags are you going to need? 3 bags, and what's each bag cost?
$3.99.
Okay, don't tell me what the answer is, just tell me what the process is going to be to figure out how much this costs. Okay, she's saying $3.99 times 3. Now, I'm going to draw a line like this. Okay, Terrence says, you know what, we can do $3.99 and take that times what value right off the bat? Anybody disagree with that? All right, let's pretend it's horse and buggy days, calculators don't exist, and we're going to multiply this out longhand, all right? So help me do this quickly, guys. What's the 3 times the 9 going to give me first of all? 27. Carry a what?
52.
3 times 9 is?
27.
27 plus 2 more would be?
29.
9. Bring a decimal down and also carry a what?
2.
Okay, and then 3 times 3 is what?
9.
9.
Then 11.
Okay.
$11.97.
$11.97. Now, how many of you guys would say, I like to do that? Multiply stuff out by hand. Well, we got some hands up. I'm shocked. Okay. I, on the other hand, don't like it. Okay. And I'll be honest with you. You guys already know that I'm a bit strange, weird.
A bit.
Okay, thank you. All right. But when I go to the grocery store, my wife and I always have a bet on what the cost of the groceries is going to be. Because I
do
usually
that.
estimate stuff, and I'm usually pretty darn close. Because when I think about stuff, I'm thinking about what's this cost going to be when we buy multiple quantities of something. I think distributively like this because aren't a lot of prices like $4.99?
Yeah.
Okay, so I'm always banking pennies in the back of my head. But guys, this is how I would have thought about this. You're saying we're talking about distributive property. We need parentheses, and here's how I think. And this is really kind of strange, but I think you'll understand what I'm talking about. First of all, we said we needed how many bags of beads?
3.
3 bags, right? So I'm going to put that there. Now, what I'm going to put here in, let's just put it in blue and see what the heck's going on. I might have a situation where I start thinking like this. Let's see, $3.99. $3.99. About how many whole dollars is that?
$3.
Well.
But with taxes, 4.
Okay, closer to $4, right? Here's how I think. I think I'm going to take this $3 times $4. Now, listen to what I'm talking about, guys. Is $4 the exact price of the bag?
Mm-hmm.
The answer is what?
No.
No, it's not. However, if I had $4, how much would I have to subtract $4 to get to the original cost of $3.99? 1 cent, right? Okay, watch what I do. I'm going to say, you know what? I really need to take 3 times $4 minus a penny here. Okay? Guys over here, Taryn's way, $3.99 times what? Times 3. We know the cost is going to be $11.97, don't we? Now think of what I've done up here. I'm saying, you know what? Let's take 3 times $4 first, and then 3 times a penny, and write this as an equivalent numerical expression to come up with a cost. Do you guys agree that what I have in blue, $4 minus a penny, is really this value, $3.99? Do you guys agree with that? Agree? Okay, so let's see. By parentheses right here, guys, what's the 3 times $4?
$12.
This is really $12 minus, I would also have to take 3 times what else? Distributive property says you got to give 3 to everything in parentheses, so I gave,
Times 1.
okay, what's 1 penny times 3? How many pennies?
3 pennies.
I have a question now. Mentally, in my head, I'm thinking, so I'm not even writing this down in my head. I'm saying, okay, it's $12 minus 3 cents. What is $12 minus 3 cents? $11.97. You see how I come up with that using distributive property? Yes? No? Yes? Okay. I'm just going to show you something here real quickly mentally. Yeah, this is $11.90. I'm sorry, 97 cents. Come on. Come on. There we go. You guys, whether you know it, can multiply in your heads better than you think you can. All right? Watch this. Taryn, I'm going to pick on you this morning.
No.
Yeah. How many can do 7 times, maybe 19 in their head real quickly? Anybody? Okay, this is how I think. I think this way. I'm just going to tell you right now the answer is 133. Boom. Okay. I think it's 133. I hope it's 133. All right. How do I do that? Well, guys, 19 is really close to what nice whole number that maybe ends in 0? 20. Okay. Couldn't I really say this is really 7 times? Let's see. If I start with a 20, what do you have to do with a 20 to rewrite that expression as 19? 20 minus what? 1. Think about it, guys. Isn't what I have right here the same as what I have right here? It is. Couldn't I distribute? What's 7 times 20 real quickly?
A number.
7 times 2. Come on.
It's 140.
14, add the 0, right? 140, and I got to take the 7 times the 1.
7.
What's 140 minus 7? I already told you the answer.
133.
133, okay? Is it easier to think about the first one, multiplying it in your head, or is it easier to think? Is it easier to think about the second one? Second one, isn't it? Okay, Maddie, question?
Yeah, I don't get how you get the 20 minus the 1, but
Isn't 19 pretty close to 20? To rewrite this problem exactly the same way, I have to call this 20 minus 1 is really my what value here? Really 19, okay? I can do 7 times 20 and 7 times 1 in my head easily, and then subtract, but doing 7 times 19 in my head, that might be more difficult. Maybe another example, how about this? How about we do 12 times, you know what, let's just do 12 times 13.
wait, okay, so what if you have like 7 times 18?
7 times
would it
18,
be
let's do it. 7 times 18, I'd probably move that up to a 20.
Okay.
Okay, 7 times, what do you gotta do to the 20 to make that an 18 still? Minus 2, right?
Oh, I get it. Okay, so like you have the 18, but you have to do whatever minus the.
You gotta write an equivalent numerical expression for that value, alright? You okay with that? Allie, question?
I was okay with everything until Matt confused me.
I'm sorry.
20 and the 2, why can't you do like 7 times the 18 minus 1, or 17 minus 1?
You could. My problem would be 7 times 17. I have a hard time
19
doing
minus 1, why can't you do that instead?
17 plus 1 maybe?
Well, instead of 20 minus 2, you have 19 minus 1.
You could do that.
So
Alright.
I thought that's what you meant.
Let me ask you a question here. Do you know 7 times 19 or 7 times 20 quicker? 20, right? I always like to try and get some kind of a number in the form of 0, okay? Because let's be honest, you should know your facts from 0 up to 9, right? And basically what I'm trying to do is rewrite this number so that this second number is a number from 0 to 9, but I would like this first number to end in a 0. Maybe another way to think of 7 times 18 would be this. Could I go 7 times 10? What would you have to do to the 10 to get back up to 18? Add a what? 10 plus what is 18?
8.
8, right? Isn't this what he's saying 7 times 18 also right here? It is, isn't it? Okay, so this would really be a 70. And then 7 times the 8 would be what? We know our facts, right? 56, okay? And then just add them up. And what's that going to add up to? $126, right? Okay. I'm guessing you guys haven't been shown that before. Is that just a hunch? Is that just a hunch?
Yeah.
You basically have just seen problems like 7 times 18 and automatically multiplied them out? Is that
Yeah.
right?
Yeah.
They taught it a different way.
Well, mentally like this?
No, use a calculator.
Oh. Okay. Alright. I always cringe when I hear that. You know, these are things, you know, I wish I could just do a class, Mrs. Miller, just how to think. Like, I'm going to go totally off topic here. Alright? Dividing by 5. Dividing big numbers by 5. Dividing big numbers by 5 is really the same as multiplying by 2. Did you know that?
Yeah.
Dividing by 5 is really almost the same as multiplying by 2 in a way. Do you guys know what 4 divided by 5 is?
20.
Huh?
20.
No,
No, that's
4 divided by 5. Grab your calculator real quickly. I want to show you something. I want to show you something. I'm just going to pick on somebody right here. Go 9 divided by 5 in your calculator.
9 divided by
9 divided by 5. Let's start that way. Tell me you get 1.8.
Yes.
See,
Okay. Do you guys have that?
Yeah. And then 4
Okay.
divided
I told you that divided by 5 is just like multiplied by 2. I wish I could teach you shortcuts. That would be a kind of a cool class
Yeah.
today, I think. Okay. I said 9 divided by 5 is always the same as taking 9 times what?
2.
Okay. You can do 9 times 2 in your head, right?
18.
18. Now move that decimal 1 to the left. Where are you at?
Oh.
Oh my gosh, 1.8!
Wait, I'm still confused.
14 divided by 5. Okay? Punch 14 divided by 5. Tell me you get 2.8.
Yeah.
Oh my gosh. Well, let's not take 14 divided by 5. Let's just turn around and take 14 times what? What's 14 times 2?
28.
28. Kick your decimal back 1. Where are you at?
2.8.
2.8. So 14 divided by 5, which was 2.8, I actually found by taking 14 times 2 and then kicking the decimal back how many places? 1. Isn't that crazy? Isn't that crazy? So you guys tell me, what's 36 divided by 5? Somebody double 36 for me.
72 would be 7.2.
7.2. Dividing by 5 is almost a form of multiplying by 2, isn't it? Crazy. Alright, let's get back to where we're supposed to be. We're way off topic right now.
Oh, no, we're perfect. That's where we are.
That's good stuff, isn't it? Okay.
I wish you could teach a class like that because it makes so much more sense.
It does. It does. And that's...
this is gonna be one long recording.
Yeah, it's alright. Okay. Alright. Well, questions on the front side then here. Any questions front side? Let's get to the gist of this then. Second page, if you will. Why don't you guys head on over to the second page. Got a lot of examples here that we're going to go ahead and use the distributive property to evaluate the expression. Alright? So a couple things we can choose to do. You know, we can follow order of operations or we can distribute. But I want you to get good at practicing distributive property right here. So guys, help me out here. To distribute this right here or rewrite an equivalent numerical expression without parentheses, what would you have to take times each other first? 2 times 9. Now I'm going to cheat this right off the bat. What is my 2 times 9 part going to get me? 18. Okay, so this is really going to become the following. This is going to become 18 plus what? Well, I got to take 2 times what else here? Which is what? 8. So this is really 18 plus 8. So can we evaluate that mentally now? What's your value?
28.
20 what?
26.
There you go. That makes sense?
Yeah. So
Okay. Real quickly, remind me, where did this 18 come from?
The 2 times 9.
The 2 distributed to the 9. Where did the plus 8 come from?
The 2 distributed to the 4.
The 2 distributed to the 4. Excellent work. Okay?
Okay, so
Maddie, yeah.
the thing I don't get is, so if you add 9 and 4 together times 2, you would get 26.
You get the same exact thing, wouldn't you?
Got it. Okay.
Makes sense?
Yeah.
Awesome. So it doesn't, remember, we're talking about everything as being equivalent. We're writing expressions in a different way, but the bottom line is this. Let me ask you a question. Okay? Bears are your favorite team, right?
Yeah.
Let's say that maybe you and Mrs. Miller are in one car to go to the Bears game, and you're going to take one certain route to get to Soldier Field, all right? Is that what they call it still?
Yeah.
Okay. And then I might say, you know what, maybe the Vikings are in town, and I'm probably going solo then. So it doesn't mean we're both going to end up at Soldier Field, right? Doesn't mean that you and I take exactly the same roads to get there. Bottom line is that we get to the same point, right? Okay. And obviously the Vikings win, right?
They lost.
I know. I got beat by a good team. Okay. Anyhow, see what I'm getting at? We're going to end up at the same spot. We're just going to take a different route to get there. And that's kind of what's going on here. Okay? All right. Let's try the next one. What am I distributing to the stuff in parentheses here? 3. So I'm going to bring this 3 that's in back to what's in front. You always got to start with what's in front in parentheses. So what's the 3 times 12 going to be when you distribute? 36, okay? Then you've got 3 times, what kind of 3 is this here in the parentheses? What kind of sign is right in front of that 3? Minus sign. What's 3 times negative 3?
0.
No, times.
Oh, 9.
What
Negative
kind
9.
of? So I'm going to write minus 9 here. Why am I putting a minus 9? Because it's 3 times a negative 3, right?
Yeah.
Okay. What is 36 minus 9? 27, good. All right. Number 3 is kind of tricky. You might want to go ahead and put a star by this one. This one's kind of tricky. I want to make sure you understand this one, all right?
Okay, so we're subtracting the 4, right? Or
No, here's the
Negative
different
4?
part. We have a 4 minus 11 right here, right?
yeah,
We're multiplying not a positive value this time, but a
negative.
negative value. So my first distribution is going to be
We
negative
have to bring the
4
4.
times positive 4, which is what?
Negative 16.
Okay, you understand the negative 16 part first. It was a negative 4 right here on the right times this positive 4. A negative times a positive 4 would be what kind of 16? Negative. Now, this is the part you really need to start paying attention to, because I'm going to shortcut this, and I think that this is going to be to your benefit as the year moves on. I always ask myself the following then. This 11 is really what kind of an 11 right here?
Negative.
It's a negative. So I'm really taking negative 4 times what here?
Negative 11.
Negative 4 times negative 11. First of all, what's a negative times a negative going to be?
Positive.
So I'm going to put my positive sign right there, okay? We've already accounted for the positive part of this value. So how about the negative 4 times negative 11? It's going to be positive how much?
44.
Here's what a shortcut might be. First number here was positive, second number was what? Negative. Anytime you're multiplying by a negative, or distributing with a negative, I should say, notice what happened to the signs. This positive became a what?
Negative.
And this minus sign became a...
Positive.
So one rule you might want to use is this. When you're bringing a negative number to your quantity, or distributing a negative number to your quantity, what are you going to do with the signs within this quantity right here when you distribute? Switch them. Does that make sense to everybody?
Yeah.
The only time you do that is when you're distributing what kind of a value?
Negative.
Did I have to switch them here?
No.
Because I was distributing with what kind of a 3? Were you distributing with a positive? You were, right? Okay. Alright, so by our rules right here, this is going to be 28. Okay. And then the next 3 is when we start getting back into that mental math idea that I was talking about. Okay, 5 times 103. Okay, so how could I rewrite 103 so it's a sum or a difference? Well, what's 103 really close to as a nice number? It's 105. Let's try and end in 0 if we can.
100.
This going in order.
What's that?
My answer was 26, 27, 28.
Is it? I don't know. Coincidence. Pure coincidence.
Was this?
Okay. I think I'll pick these 6 numbers as my lottery numbers tonight, okay? I'm going to write this, okay. You guys all agree that 103 is really close to 100, right? Okay, so how could I rewrite 103 if one of my numbers is 100? What would you have to do to the 100 to bump that up to a 103? Well, wouldn't you add a 3? Isn't my quantity of 100 plus 3 really the same as this 103 right here? Okay, is it easy to take 5 times 100 in your head? What is that? Oh, come on. 5 times 100? 500. And then 5 times the 3. What do you got? 5 times 3.
15.
So what's the sum going to be here when you evaluate this?
515.
515. So I just blew your theory out of the water, Madison. That answer's not 29. Okay. What I really like to get good at is like 5 and 6 just to make sure you know how to rewrite these. 3.8 is really close to what whole number? 4. Okay. You guys agree that I can write this as 4 times 4 minus 0.2? Isn't 4 minus 0.2 3.8? It is, isn't it? Okay. So distribute. How about the 4 and the 4? What's that?
16.
And then 4 times negative 0.2 would be negative 0.8. Okay. Anybody know what 16 minus 8 tenths or 0.8 is? If you're not sure, punch it in. Huh? No, it's 0.8. It's like $16 minus 80 cents. It's like $16 minus 80 cents.
15.2.
15.2. Good. Okay. What's 6.03 really close to as a whole number? Closer to 6, isn't it? How are you going to rewrite 6.03? What plus what? So 6 and 300, so 6 plus what? Point. Point what? 0.03. There you go. So this becomes 3 times 6 plus 0.03. What's 3 times 6, everybody? 18. And then this will be plus 0.09. That's like $18 plus 9 cents. What's your value? It's like $18 plus 9 cents. What's your value?
18.9.
09, right, Tim? Okay. All right. You guys have that down?
C.
C?
C, senor.
I knew somebody was going to get smart and do that. Guess I'll have to double the homework assignment, even this is more.
No, senor.
It's not a senor.
Stop talking Spanish. Why?
That's a scoop.
What?
We don't want extra
Yes.
homework. We do not.
I agree with John.
Okay.
Extra homework is neat, so.
Let's rock and roll with this right here, see if we can't figure out what's going on. Now, guys, the expressions we just looked at on the last page, or the previous page, I should say, were all numerical, okay? We've already talked about the idea that not everything's going to be numerical. And in example 2, we're all of a sudden talking about writing not numerical expressions, but what? What's underlined up there? Variable expression. So it says, use a distributive property to write an equivalent variable expression. This is the part where you're distributing to get rid of parentheses. So this is pretty easy to do, guys. Same thing is going to apply. To rewrite an equivalent expression with variables right here, I'm going to take 2 times what first?
X.
2 times x. So the only thing I can write for this part is 2x. Okay? Everybody see that? What do I also have to distribute the 2 to as well inside that quantity? 10. So what am I going to have at the end? 2x plus what? No. 2 times 10. 20, right? Okay. Let's see. Add an expression with parentheses. Now you have it without. They're the same thing because what property did you apply? Distributed. Okay. What are you going to distribute to the m plus 3 here, everybody? So what's negative 4 times m going to be? Well, I don't know what the heck m is, so the only thing I can call it is negative 4 what? Call it negative 4m, right? Then I also need to take a negative 4 times what else?
3.
A positive 3. How about a negative 4 times a positive 3 there?
12. Negative 12.
So I got to write minus 12. By the way, just to back up, what kind of number were you distributing with? What kind of number did I distribute with right here? Negative. What's that going to do to all the signs inside that quantity?
Flip them.
They were all positive. Is everything negative over here now? Flipped everything, right? Okay. Same thing over here. What am I distributing? Well, negative 3. Now this is a little trickier, but what's the negative 3 times 2y? The only thing I multiply is a negative 3 and a positive 2, right? Which is negative 6, but which variable is going to be attached to that? Okay, negative 6y. Then, be careful on this part. The 2 values that are getting multiplied are a negative 3 and a negative 6. So a negative times a negative there will be a, so plus what here? Well, plus 18. Okay? Very good. You guys good so far?
Yes.
Let me know you've got it down. All you do is take what's outside, multiply it to everything on the inside.
Are you gonna make us do these?
I'm going to have you try these 2 right here.
Ew.
Go ahead and distribute these 2. See what you come up with. Write expression, an equivalent expression, one without parentheses in each case. Go ahead and try those. When you've got them, check with a neighbor around you, see if you agree. Disagree, talk about why you disagree. What? You didn't see anything.
Yes, I did.
I saw you too.
Go ahead and distribute. Distribute.
I got it.
Here it goes.
All right, let's take a look at these 2 things right here. We're going to end with this today. Pick up the rest of this first thing tomorrow. But who's got an expression on this first one right here? Let me grab my pointer. Hang on 1 second. Okay, who's got the first one for me? Chelsea, I haven't heard from you yet today.
4x plus 20.
Excellent. The 4x is coming from 4x. How many have 4x plus 28? Good. Somebody different for the second one. Be careful on signs. Tim, you got it? Tim J?
get 12M plus 21.
So you're telling me that since I was distributing with a negative value out front, all my signs in the quantity should stay the same or flip?
Flip.
Okay. How many had both of those?
And
Okay, good. All right. I think that's a good place to stop right there. Don't lose track of your notes. We've got some stuff to do quick quiz-wise. But I do need to get you a short book assignment, so let me stop this here quickly.